Hello, and welcome to our VMware Explore session. Today, we'll be discussing multi-cloud native data with Spring and VMware Data Solutions. My name is Morgan Iverson, and I'm a back-end engineer for Workspace ONE. Demetrious.
Hi, my name is Demetrious Robinson, and I'm a consulting software engineer for Tanzu Labs. Gregory?
And hello, everyone. My name is Gregory Green. I am a solution engineer, and I have the privilege of working with awesome people like Morgan and Demetrius. And here is our agenda for today. We're going to walk through an example application that we built, and it runs across multiple clouds, and it uses VMware Data Solutions. But we want to start out by showing you the end product. This application is based on a loyalty rewards program. If you're like me, you probably have multiple rewards accounts with retail stores such as supermarket, clothing, or hardware stores. I appreciate getting discounts based on my loyalty to a particular brand. It's even better if the promotion rewards is based on products I need and will most likely buy. The architecture for this application looks something like this. We're utilizing VMware data products running across multiple clouds. Each application is developed using Spring. We have tested the solution across two clouds. There's the analytical cloud at the bottom and a transactional cloud at the top. The web application in the transactional cloud is where we visualize the customer's favorite products and the real-time promotion recommendations. The web app gets its data from VMware Gemfire. There's a sync app that populates VMware Gemfire based on data from RabbitMQ. RabbitMQ is running across both clouds. It's used to move data such as from the analytical to the transactional cloud. All customer orders and product information is stored in my favorite relational database, Postgres. There's a Spring app that accepts orders from stores running at the edge and product data from an enterprise product catalog. The Spring Analytical app is the glue. It stores all of the streaming data from Rabbit into Postgres. It also performs machine learning workloads to recommend to recommend products based on buying history, association rules, and customer favorites. Let me show you the app. So here, as I mentioned, the application is running, and as soon as I log in, it shows me my customer favorites or my favorite products that I typically buy. Now I'm going to simulate purchasing a new order in this command shell. And this data is sent to the analytical cloud, and the results are displayed in the transactional cloud. Now let's talk a little bit more about how this is actually architected. First, we'll go into multi-cloud. Well, I have been blessed with the opportunity to talk to many different customers that have been deploying really cool solutions in the cloud. Most of them utilize more than one cloud for various workloads. In fact, based on VMware's research, 73% of customers are using more than one cloud for various reasons. There's not a single public cloud that has 100% guarantees for uptime, I should say. In fact, I can remember demoing some cloud solution running in a public cloud where the region where my services was running had an outage, and it was embarrassing. Some customers are looking to lower their risk by running workloads across multiple clouds in different geographical locations. There are some clouds that are not available in specific locations, and other companies are stressed that they intentionally build their solutions to support or move from one cloud to another in order to negotiate a cheaper price amongst their cloud providers. I also know that there's different teams within various companies that have different preferences for clouds based on their team's skill sets. This is just a glimpse of the various reasons why companies support multiple clouds. This slide sums up what I've seen in the field as customers are trying to implement multi cloud data solutions on their own. For example, they're picking the most popular open source solution and relying on the community to support critical workloads. They often come to us after their solutions are already in production and there's some critical issue that they need urgent help from VMware to support. They have a group of really smart engineers that are scripting environments and trying to maintain a balance of container technologies like Docker using Linux based scripts. Often they start out great, but over time, it's just not easy to maintain those solutions, especially as they have people leaving the company. When they try to move from one platform to another, they're limited on how many platforms they can support. They want to move to public clouds, and they may start with one cloud, but it's hard to adopt more than one cloud and still maintain standards. Over time, this leads to increased maintenance costs because they can't keep up with all of the vulnerabilities, especially in the open source solutions. So this exposes them sometimes to security issues such as CVEs or common vulnerabilities and exposures. The good news is VMware can help to address these issues for both the applications and the data. But what is cloud native data? Today, many companies come to VMware because they want to run their software in the cloud. We don't have to convince them on the value of the cloud. The cloud has proven to provide a powerful way to provision infrastructure to run software applications. The applications run effectively on the cloud. They must, in order for them to run effectively on the cloud, I should say, they must be stateless. Many of you are familiar with the 12 factor based principles that points out this fact. I personally can't imagine an application that's useful without storing any sort of state or data information. So the state or data is traditionally stored in what we call a backend service, and that is what I refer to as a data service. And there's typically just two main categories for these data services. They either handle data movement or data in motion, and the other category is data management, also referred to as data at rest. The cloud native data services, whether they handle data movement or data management, should have these principles in mind. The application team should be able to self provision and attach your data services to cloud native based applications. They should support various cloud options such as on premise, public cloud, hybrid, or even multi cloud requirements. Data services should support scaling with the application. They should support overcoming instabilities in the infrastructure to maintain high availability with fault tolerance. Infrastructure issues should be seamless to both apps and data. And they absolutely must be secure, especially when they run in the public cloud. Now, let's talk about the patterns. Now, this slide is an abstraction of the architecture of the application I just showed you. Some companies like to know exactly which workloads are running in what specific clouds. For example, transactional or fast data workloads can run in one cloud and analytical workloads in another. In the transactional cloud, the applications can be designed based on the CQRS pattern, which stands for Command and Query Responsibility Segregation. In this case, the command apps, like the sync app in our example, can perform all of the write operations. The query app, such as the web application in our example, can perform all of the read operations. This pattern allows us to scale your read and write workloads independently based on your requirements. This has proven to be useful, especially for transactional workloads that have more writes than reads or vice versa. Now, for event streaming solutions, they're needed when you need to move data. For example, when you need to share information amongst applications reliably. Event streaming solutions like VMware RabbitMQ provide low latency between the time the app publishes some information to the times another app consumes that information. Event streaming solutions support very high throughput. This should typically be higher than data management solutions, in the order of magnitude of millions of events or messages per second. Many event streaming solutions like RabbitMQ provide flexible routing. So whether you're moving data between apps or between clouds is configurable within your event streaming solution. A NoSQL caching solution are all about managing or storing data. Many of these NoSQL caching solutions, like VMware Gemfire, support extremely low latency in-memory read-write operations, where the response time can be less than 1 millisecond. They support high throughput by dividing or partitioning the data across multiple servers. This allows read and write operations to be done in parallel across servers in a very scalable fashion. They provide flexible storage so that you can write your data exactly how it's needed, and sometimes in nested formats where you have objects inside of objects. And finally, the VMware Gemfire supports event-driven architectures where you can respond to changes in your data in real time for those time-sensitive data operations. A relational database is another type of data management service. The main benefit of a relational database is its support of the industry standard SQL language or structured query language. SQL allows developers, administrators, and even data scientists to access data in a well-known format. Most relational databases are great for analytics because they provide or they support SQL functions that perform or determine trends in the data based on averages, max values, and other statistics. Relational databases are also good for transactional workloads because you can update many different data sets and have the changes committed or rolled back with a single unit of work. This maintains data consistency, which means that the data that I write is always the data that I read out. Data consistency is the main reason why relational databases such as MySQL and Postgres are the most trusted solutions for data management or data storage. A massively parallel processing database, or an MPP, is another database that supports the SQL interface. An MPP solution like VMware Greenplum supports larger volumes of data. You can manage petabytes of data by dividing it across multiple servers. MPP databases are great for analytics because, in addition to providing useful statistics, functions, I should say, developers can also develop their machine learning, artificial intelligence custom functions that run inside the database itself. The functions can be written in popular languages like Python and R. Greenplum supports federated access. This means instead of pushing your data to Greenplum, Greenplum can pull that data from external systems on demand. This is a great option to simplify your analytical data access needs. So you should know that VMware has proven data solutions for these common application needs. The most popular open source message broker, RabbitMQ, is managed by VMware. MasterCard uses Gemfire to service over a billion transactions per day. It's also trusted for critical workloads for companies like India and China Railways that service millions of travelers per day. Not only that, VMware supports the most popular relational databases, MySQL and Postgres. And as mentioned, it supports Greenplum, which is one of the most popular open source MPP databases. So VMware can be a trusted solution for not only applications and data. So VMware is also the primary owners of Spring. Spring is one of the most popular Java-based development frameworks. To walk us through more or to tell us more about Spring, I'll have my colleague Morgan walk us through that information. Morgan, take it away.
Hi, y'all. I'm going to spend the next few minutes talking about how we were able to integrate all these data services into our application using VMware Tanzu's Spring framework. Spring allows us to easily integrate with VMware's RabbitMQ. RabbitMQ is an open source message broker. Message brokers simplify communication between services by removing their dependence on each other and acting as the sole communicator. RabbitMQ is extremely useful because of all of its core features. We have lots of control over how and where our messages are sent, organized, and created. Spring supports all of the RabbitMQ protocols like AMQP and the new Rabbit Streams, which is similar to Kafka. Spring's AMQP project holds the two frameworks we use in our retail app. The first is Spring AMQP. This part of the project is used for creation of the core RabbitMQ messaging entities like exchanges and queue. It also supports converting messages to business domain objects. The second part of the project is Spring Rabbit. Spring Rabbit provides the wrapper code, including the Rabbit template entity that we can inject into a service class according to Spring best practices. In this project, we created the customer order data service to send customer order information to our RabbitMQ message broker. You can find this service class in the Retail Analytics app in our GitHub repository. Spring Data is a big Spring project that facilitates many data interactions using Spring's core features like dependency injection. Spring Data allows us to choose from many database services like Postgres, MySQL, or Greenplum, and supports use of multiple databases. My favorite feature of Spring Data is the relational data mapping. We can create a traditional Java object, and Spring does all the work to convert that object into a data structure that can be stored in a database of our choice. Another great feature of Spring Data is database migrations using tools like Liquidbase. Spring supports database creation and management in a single file. We'll be using Spring Data Repository to create a repository and Spring Data JDBC to interact with our repository. In our retail app, we built a CRUD repository called Customer Order Repository to store objects of type Customer Order Entity in our Postgres database that we built using a Liquidbase SQL file. This repository performs basic operations inherited from the CRUD repository, like save and delete. We also created a repository called Product JDBC repository that uses Spring Data JDBC to perform custom queries to our Postgres database. These queries are significantly more complex than those inherited from the CRUD repository. And Spring Data provided us with a clean way to perform complex queries. You can find both repositories, like the liquid-based file and our complex query strings, in the Retail Analytics app in our GitHub repository. We also will use Spring's data project in our interactions with VMware Gemfire. As mentioned, Gemfire is a NoSQL database or caching framework. The purpose of caching is to reduce latency of gathering data from its source by storing some data in memory. With VMware Gemfire, you can perform many of the same operations as you would with databases, including CRUD operations and some others that help safely save, manage, monitor, and improve serialization performance and connection management. In our retail app, we implemented Gemfire as a caching service using Spring Data for Redis. Using this Spring project, we connected our Gemfire cluster and bound 3 repositories: the product repository, promotion repository, and the customer favorites repository. Historical data, like all customer orders, is stored in Postgres, but real-time data, like customer favorites and promotions, is saved in VMware Gemfire for fast read access. Visit our GitHub repository to see how our retail cache sync app and the retail web app use Gemfire as a caching service. Now, Demetrious will tell you how we use Kubernetes to run all these data services in the cloud.
Thank you, Morgan. As an engineer with Tanzu Labs, I've had the privilege of working with our clients over the past several years to help them deploy their own apps to production environments. I've helped them deploy apps to both non-Kubernetes and Kubernetes environments. And when it comes to working with Kubernetes, it's similar to working with any other platform. One major advantage, however, is that Kubernetes is cloud/platform or environment agnostic. What that means is that we can run it on the cloud, on-prem, or even on the edge. It provides us with an abstraction layer to easily provision, deploy, and maintain our apps and services across multiple environments. For example, here we have our loyalty rewards application where we're utilizing a few different VMware products, such as VMware RabbitMQ, VMware Gemfire, and VMware SQL. In all of these products, VMware utilizes the operator pattern to help them automate the management of complex applications and services. For example, when it comes to running RabbitMQ on Kubernetes, we can easily provision a RabbitMQ cluster using VMware RabbitMQ. As you can see here, we have a simple YAML file that contains the definition of a 3-node, 4 CPU, 8 GB memory RabbitMQ cluster, complete with load balancing. Now, let's say that we needed to scale horizontally. With Kubernetes, it's as simple as altering the replica number in our YAML file and reapplying it to the cluster. Utilizing VMware Gemfire is no different. With a simple YAML file, I'm able to deploy a multi-node Gemfire cluster. And just like with RabbitMQ, we can vertically and or horizontally scale as needed. We can even dynamically enable add-ons on the fly, such as Gemfire for Redis. Moving on to VMware SQL, I'm starting to see a pattern here. Are you? Imagine we wanted to deploy a Postgres server with VMware SQL. Just like with the previous data solutions we used, we can set up a cluster in a few lines of YAML. In addition to cluster setup and scaling the service as needed, we can even enable high availability and backups for data integrity and disaster recovery. We can do all of this from our YAML files. Now, you tell me, would you rather set all of this up for yourself, or would you be open to having Kubernetes do some of the heavy lifting for you?
All right, thank you for that, Demetrious. So VMware has proven to be a trusted provider of software infrastructure to run applications. Today, you can run your applications consistently across multiple clouds using the power of Kubernetes. Your data services, whether it's movement or management, can run natively on the cloud. And VMware supports a wide range of data solutions that can all be utilized by your Spring Boot-based applications. Don't forget to take our survey and stay connected with us on LinkedIn. And as Morgan mentioned, please check out the GitHub where you can look through all of the source code that we use for the application. Thank you. Enjoy the rest of VMware Explore.